tasks and functions. So let us quickly brush up the previous concepts. So we have started with the tasks and functions in system Verilog. So tasks and functions, both tasks should not have, sorry, tasks can have delay and wait statements in both system Verilog and Verilog, whereas functions cannot have delays and wait statements both in Verilog and system Verilog. And in case of Verilog, functions cannot have output arguments. It should have only input arguments, and in-out arguments are also not allowed in case of functions. Whereas in case of tasks, in case of Verilog, in case of tasks, it can have input as well as output arguments. And in case of Verilog, functions cannot be void type, but in case of system Verilog, functions can be of void type. So this we have discussed in our previous sessions. And a function can call a other function, whereas a function cannot call another task, whereas a task can call a function as well as a task. And in system Verilog, we have also discussed that we can we have a keyword called return keyword. With the help of return keyword, we can get the values, and the simulator will get out of the task or function without entirely completing the function or task. So in functions in system Verilog, we have also discussed that we can have input arguments, output arguments, and function should complete in 0 time units in case of system Verilog. And functions can be void. We have discussed about this void functions in system Verilog. And we have also discussed the usage of functions, where we are using the functions and tasks. We are using functions and tasks in scenarios where we want the logic, where the logic is uh, repeatedly used. So in those cases, we will use the functions and tasks. Here we have also discussed that a task can call a task as well as a function, whereas a function cannot call a task; it can call only another function. And we have discussed one example about void functions and non-void functions. So in this session, we will start with pass by value and pass by reference. So we can pass the arguments to our functions and tasks by two methods. First one is pass by value, and second method is pass by reference. So there are two methods for passing the values to our functions or tasks. First one is pass by value, and second one is pass by reference. And we have also another method which is called as pass by name. So basically we have three methods through which we can pass arguments to our functions or tasks, which are pass by value, pass by reference, and pass by name. First we will start discussing about pass by value. So this pass by value method is also present in our Verilog also. So arguments can also be passed as well as by position, and tasks and functions arguments can be default values. And okay, so we will take one example directly. So if we have a module called example, and here if we have two variables declared as integers, integer a and integer b, and let us take a function of return type int, and the name of the function is sum, and the inputs are input a and input b, and the output is c. And let us take another variable as input sum. So we can there is no need to use begin end in case of system Verilog functions and tasks, whereas in Verilog we should use begin and end. So here no need to use begin and end in the functions. So the sum will be, sorry, the output c will be equal to a plus b. So this function is basically performing c is equal to a plus b, and I'm ending this function, end function. So this is the function I'm declaring, and within an initial beginning block, I'm calling the function and I'm storing the value in sum, which is equal to, okay, I will take sum underscore output. So I'm storing the output in sum underscore output, and I'm calling the function sum, and I'm passing the values. As the method is passed by value, so I'm passing the values by the method passed by value. So I'm passing the values directly 0 comma 1, and I'm collecting the values in this variable. So sorry, so I'm calling the function sum, and I'm passing the values, and I'm collecting the values in sum underscore op variable, and ending the initial beginning block. So I'm calling the function. So this is my function sum, and my input arguments are a comma b, and my output argument is sum. So in this method of pass by value, I am passing the value of 0 to a and 1 to b. So my output c will be calculated, that is equal to 0 plus 1, and will be stored in output c. So here it is output c. So the variable which is declared in the argument of this function sum is c. So it will be stored in the output c, and it will be passed to sum underscore op. So like this, I can pass the values. I can pass the values to this arguments of the function, and I can call the function one more time, and I can pass the values directly, and I can collect it in my variable sum underscore op. So this is the first method, which is the pass by value. So is this clear for everyone? Is there any doubt? So in pass by value, we are directly passing the value, hardcore value 0, 1 or 1, 2 to this variables a comma b. So in this method, we are directly passing the values. That's it. Is this clear? Nothing. In pass by value, we are directly passing the values to the function arguments. Is it okay?
Okay. Okay.
Yeah. So now our second method is pass by. Okay, before going into pass by reference, we will discuss about pass by name, arguments passing by name. So again, I have a module called example, and I'm taking one variable int m, which is equal to 10, and int n, which is equal to 11, and I will take one more variable as int q. So these I have taken three variables, and I'm declaring a function of return type int, and my function name is compute, and my input arguments are a, another input argument is b, and my output argument is c, and c is equal to a plus b. Simple function which is adding two numbers and ending the function. So within an initial beginning block, I am calling my function compute, and I will pass this values m comma n, and I'm going to collect it in the variable q, and ending this, and ending the module. So in case of pass by name, what I'm doing is I have declared one variable called m of int data type and n of int data type, and I'm storing the value of m is equal to 10 and value of n is equal to 11. So instead of passing the value directly, what I'm doing, I'm passing the variable m and n. So what happens here, there is my function called compute, and my input arguments of this function are a, b, and my output argument is c. So m is copied into a and n is copied into b, and the output is given to q. So instead of passing 0 comma 1 or 1 comma 2 as arguments to my function, what I am doing is I am declaring some variables and I am passing these variables to my function like name. So I'm giving my variables to this arguments. So a will be allocated to m, which is equal to 10, and b will be allocated to n, which is equal to 11. So my output c will be equal to 10 plus 11, that is equal to 21. So this is how we can pass the arguments by name. So is this clear? This method is clear? Got it?
Got it.
So this is the second method in which we can pass the arguments by name. So in case of pass by value and pass by name, what happening is, for example, when we are calling a function, say compute, and when we are passing the value by, and when we are passing the value of the argument by pass by value method or pass by name method, any of the method, for say suppose pass by value method, and we are collecting it in some variable c. So what happens, we have a function here declared, function int compute a comma b comma output sum. So I've already told you that if I haven't declared the direction, then it is by default input, and sum is equal to a plus b and ending the function. So here what is happening is the value is getting stored into the variable a, and this value is getting stored into the variable b. So what happens, for variable a local storage will be created. A local storage inside the function will be created for both the variables. So when we pass the values, this is A, this is the storage for A, this is the local storage for B, and when we pass the values to this function through this argument, so this value is getting stored in this local storage. So when we are passing the values, these values are getting stored into this local storage. So if I uh, change this logic, say suppose I want to increment the value of A and I want to increment the value of B, and wait a minute, in a fresh page I will take it. So I will take a module TB and I'm going to write a take some variables int A, int B, and within an initial beginning block I will take int A is equal to 5 and int B is equal to 6. So within an initial beginning block, what I'm going to do is I will increment A plus plus and B plus plus, and I will display this values. Dollar display A is equal to percentage D comma A, and same dollar display b is equal to percentage d comma b. So listen this carefully. So I'm incrementing the values of a plus plus and b plus plus, and I will write here something. A is equal to percentage d. This is outside the function. I'm writing this in the display function only. Same here also. This is outside the function. I'm displaying like this, and here I will declare the function which is called compute, and my input arguments are m comma n comma output p, and I'm incrementing m plus plus and n plus plus, ending the function. Or else I will write m is equal to m plus 2 and n is equal to n plus 2. So here um, I will display the values also. Dollar display the value of m inside the, so the value of m comma n inside the function is percentage d comma m comma n, and ending the function. Now I will pass the value of a comma b here only. So compute I will pass the values of a comma b, and I will store it in some variable. No need to pass the variable also, a comma. So let's analyze this. So first I am calling the function called compute, and I am passing the values of a comma b, which is 5 comma 6. So I am passing the values of 5 and the values of 6 to my function. This is my function. I am passing the values of 5 comma 6. So what happens internally, the function will store the values of 5 comma 6 into some local storage which is allocated for m and n. So the value of m will be equal to 5 and the value of n will be equal to 6. And what I am doing inside the function, I am incrementing m by 2 and n by 2. So here what happens, it will be equal to 7 and this will be equal to 6 plus 2, which is equal to 8. So the value of m is equal to 7 and the value of n is equal to 8, and outside my value of a is equal to 5 and b is equal to 6. So I'm making change to the values a and b inside the function. I'm making change to the values of a comma b inside the function to 7 comma 8. So there will be any change to the output global variables a comma b when I am changing the variables inside this function? Will there be any change? Any answer?
No.
Yeah, no. So any changes which are made inside the function are not getting reflected outside the function. So this is very, very important point. So any changes which are made to the arguments inside the function are not reflected, we can say globally. So any changes which are made inside the function are not reflected globally. I am deleting this step. So no need of incrementing this a plus plus or b plus plus. Just I am displaying the value of a and b. So when we see the display statement, then there will be no change in the values of a and b when we are changing the values inside the function. Here this step is not needed, a plus plus and b plus plus. So just I am displaying the values of a and b. When we use the simulator and check it, so then we can see that if we change the values of the arguments inside the function, then they are not reflected outside. So there is no change in the arguments which are made. So there is no changes reflected globally when we change the arguments inside the function. Is this clear? Because we are storing these arguments into a separate local storage. So that's why we are not getting any changes globally. Is this clear? Pass by reference. Where is it? Yeah. So coming to arguments passing by reference. So see this. Pass by reference. So same. First I will declare a module called test, and I will declare int a is equal to 10 and int b is equal to 11, and I will declare a function called compute, and for this my input arguments are m comma n, and return type is int, and output is some variable output q, and I'm incrementing m is equal to m plus 2 and n is equal to n plus 2, ending the function. And within an initial beginning block, and inside this function I can write two display statements for displaying the values of m and n. For displaying the values of m and n, and within an initial beginning block I will display the values of, first I will call the function compute, and I will pass the values of a comma b. Now I will display the values of a comma b. Normal display statement we can use. So wait a minute. So for using pass by reference method, we should use the keyword ref. So I will use the keyword ref m comma ref n, and my output is. So for using the this method pass by reference method, I should use the keyword ref. So then only it will work. So simply I'm declaring two variables int a and int b, and I'm passing the values of a and b to my function, and this is my pass by reference method. So I'm using the keyword ref before this arguments m and n, and I'm incrementing the value of m is equal to m plus 2 and n is equal to n plus 2, and I'm displaying the values inside the function. And within an initial beginning block, I'm calling the function and passing the values of a comma b, and I'm displaying the values of a comma b, and ending this and ending the module. So my value of a is equal to 10 and b is equal to 11, and I'm passing the value of a to my function argument m, which is a reference, which I've used ref keyword with the m variable, and b is also 11, and I've used ref keyword with the variable n. So this is my function. So what happens when we use the keyword ref, then the variable is shared. So the any changes which are made to my arguments are also get reflected globally. So any changes which made to this arguments m comma n, these changes are reflected globally. So what happening inside my function m is equal to m plus 2 and n is equal to n plus 2. So m which is equal to a, so that is equal to 12, so m will be equal to 12 and n will be is equal to 13. So these values are reflected back globally to my original variables a comma b. So a will be equal to 12 and b will be is equal to 13. So if we use the keyword ref, then any changes which are made to these arguments internally inside the function are reflected back globally. So basically the memory is a shared memory, that is all the arguments and the variables are local shared in the same memory. So um, any changes made locally are reflected back globally. So here when we try to display the values of a comma b, then we get a is equal to 12 and b is equal to 13. I will write it here. So any changes which are made locally inside the function are reflected globally. So this is how when we pass the variables using pass by reference. Is this clear? Is this clear?
Yeah, clear.
So normally when we pass the values by arguments, then the changes which are made uh, locally are not reflected globally. But when we pass the values by reference, then the changes which are made locally are reflected back globally. So by using the keyword ref, we can find whether our argument has undergone any change or not. Like that, in that scenarios when we want to check whether our value is getting changed or not internally, we can use the keyword ref, so that we can get to know that if there any changes are getting happen to our value or not. So this is pass by value, pass by argument, and pass by reference in system Verilog tasks and functions. We can use this with the tasks also. I will discuss with the functions. You can use with task also. So is this clear for everyone? If you are having any doubt, you can ask me. So we have one more topic called static tasks or function, and another is automatic task and function. So we will discuss it. So for this, again, I will take one model example, and I will take two variables, say 2 and n is equal to 3, and I will take a static task, static return type. Wait a minute. So before going into static tasks and automatic task or function, so we will understand the difference between static and automatic. So basically static is nothing but a shared memory, whereas automatic means there will be dynamic memory allocation. or a separate memory will be created for every task call. For example, in static task, everything is stored in same memory locations. But um, whereas in case of automatic, every time we call a task or function, a new memory will be created for the variables. For example, we will take this uh, module. For example, uh, so by default, any function or task which is declared inside this module is static in nature. So by default, any function or task which is declared inside a module is static in nature. So please remember, this is a very important point. So any function or task which is declared inside a module is static in nature. So for example, so we don't need to explicitly mention our task or function to be static, because any function or task which is declared inside our module is static in nature. So I will take one example: int m is equal to 3 and int n is equal to 4, and I will take one function and return type is int, and my input arguments are a comma b, and I'll take one output argument as c. Wait a minute. So for this example, I will just display the values. So function void a comma, I'll take two values and I will increment a plus plus and b plus plus and end the function. So within an initial beginning block, I'll call the function function void. My function name is say incr. So I will call incr function and I will pass the values of 3 comma 4. And again, sorry, okay, so no need to write this command also. I'll pass the values of int 3 comma 4, and again I will call the function and I will pass the values of 10 comma 11 and incr 1 comma, ending this and ending the module. So I've declared a function called incr. In this function, I'm incrementing m plus plus and n to n plus plus. So my input arguments are m comma n, and within an initial beginning block, first I'm passing the values of m is equal to 3 and n is equal to 4. So whenever I'm calling the function incr 3 comma 4, so let me display here something. So I will write here $display value of a and $display value of b. Like this I will write some display statements. So tell me, uh, what will be the value of a comma b when I call the function incr and when I pass the values of 3 comma 4? What will be the values of a comma b? So it will be equal to 4 comma 5. And in the next step, I'm again calling the value of and I'm again calling the function incr and I'm passing the values 10 comma 11. So what will be the value now? So with this example, we cannot understand more clearly. I will take a is equal to a plus 3 and b is equal to b plus 4. Now, when I am passing the values of 3 comma 4, so what will be the value of a and b? 3 plus 3, which is equal to 6, and 4 plus 4, which is equal to 8. Is this okay? So I'm changing the logic. A is equal to a plus 3 and b is equal to b plus 4.
Yeah. Okay.
Next, I'm calling again the function incr and passing the values of 10 comma 11. So what will be my values of a comma b? I'm passing 10 comma 11.
13 and 14.
No. So this is a static task. So since I have called my function incr initially and I have passed the values of 3 comma 4, so my value of a will be equal to 6 and b will be equal to 8. So this is my value, and whenever I call my function again incr 10 comma 11, so what will be my value, which is equal to initial value of a is equal to 6. Okay, sorry. Okay, I will take one more example. So I will not pass any arguments for better understanding. Sorry for the confusion. I am not passing any values. So now, tell me, so I'm just calling the function once, that is incr, and I'm not passing the values to this function. So this is a void function, no inputs and no outputs, and by default this is int. So by default a will be equal to 0 and b will be equal to 0. So now tell me what will be the output. The value of a will be equal to, is this right? Is this clear?
Clear.
Next, and I'm calling the function again. So what will be my output? Is this right? So previously I have called my function, so the value of a will be equal to 3 and b will be equal to 3. So if I again call my function, then the value of 3 will be incremented to 6 and b will be incremented to 6. Is this clear?
Yeah.
And whenever I call my function again, then the value of 6 will be incremented to 9 and this will be incremented to 9. So in case of static functions or static tasks, my values are getting stored in the same variable, same memory, so static memory. So the previous value is getting incremented in the case of static tasks and static functions whenever we call the function. So for every call, the same memory is getting called. So for example, so this will be some memory created for the function, a local memory will be created, and the variables a and b will be stored. So whenever we call this function, which is incr, so first time when we call it, it will refer to this variables which is stored in the memory, and it will be incremented and it will be stored in the same memory. A will be equal to 3 and b will be equal to 3. So this will basically override the previous values, and this values will be updated to 3 and 3. So whenever I call this function again incr, so it will go to the same memory and it will take these values and it will override these values and it will store some new values here. A will be equal to 6 and b will be equal to 6, and old values will be removed and the new values will be updated in the same memory locations. So is this clear? So that's why we are getting the incremented values like this. Is this clear?
Yeah.
So when I take a automatic function automatic, and I will say incr, let's say this is a void function, and I'm taking again a is equal to a plus 3 and b is equal to b plus, ending the function. So I'm calling this function for once inc here. Now what happens? The value of a will be equal to 3 and b will be equal to 3. Is this clear? I'm calling the function inc here. So here the value of a will be equal to 3 and b will be equal to 3 again, because in case of automatic function, first I'm calling this function inc here. So it is pointing to one memory location where a is equal to 0 and b is equal to 0, and a is equal to 3 and b is equal to 3 will be stored in this memory location. Whenever I'm calling the function again incr, then it will not go to the previous location, but it will go to the new memory location, and there a will be equal to 0 and b will be equal to 0 only present. So the old values, so in case of automatic function or task, the old values are not overridden. For every function call or task, for every time when we call a function or task, a new memory is uh, a new memory will be created, the and the variables will be incremented like this. So a new memory location will be created. So like this, when we call the function again, then a new memory will be created and the new values will be incremented like this. So every time we call the function, the value will be equal to 3 and b will be equal to 3. So is this clear? This is clear?